Welcome to probability. I will assume you know a little bit about probability. Most people have. And that might be through playing cards or gambling a little bit or playing the lottery or having an interest in the likelihood of some stock performance. But I think it's a safe assumption that everyone has had a little bit of an exposure to probability. One of the things to remember is probability is calculated, but what it represents is how often this outcome is observed in the long run. So let's think about coin flips. If I had a coin in my hand and I flip it and I ask you, what's the likelihood that coin lands on heads? You know the answer without thinking. But if I were to flip the coin 10 times, you know that it's not going to come out exactly 50% of the time heads and tails. What that probability represents, what that 50% represents, is in the long run, after millions and millions of coin flips, you will observe half of the time heads, half of the time tails. But in the short run, you won't observe that. So keep that in mind as we go through this discussion. There are a few definitions. An experiment, we've already been exposed to this. An experiment is something that produces a random outcome. We've looked at you could look at an experiment as a survey. You're going to ask these questions, that's the process, and you don't know what responses you'll get. And those are the random, uncertain, unbiased outcomes. Outcomes are the results of that experiment. So the results of your survey questions will be your outcomes. If you are playing cards and you're dealing, the outcome is what you get, what you're dealt. Outcomes are very rarely used by themselves. Normally we group them together. So when you group one or more outcomes together, we call those events. Okay, pretty straightforward. Now let's talk about how to calculate a probability. And there's really only one way to do it. A probability is a ratio. The classical method is when you have a situation where the outcomes are equally likely, like coin flips and decks of cards and a pair of dice. You would take a particular outcome, like spades. And to calculate the probability of a spade, you would calculate the number of ways to get a spade. And there are 13 ways. And you would divide that by the total number of outcomes. Well, there are 52 cards in my deck. So there are 13 spades out of 52 cards. So the probability of a spade is 13 out of 52, or 1/4. Or you could use the empirical method, which means you must have data. So instead of taking how many times can I get this outcome out of all the possibilities, if you have data, you can count up, well, how many times did that thing happen? How many times did that outcome happen? How many times did I get this particular response? Divided by how many people did I talk to, or the sample size. There is another way to arrive at a probability. It's based on a subject matter expert's opinion. So for what we will do in the class, we will leave everything to the two calculation methods that we just spoke about.